I hope everyone's doing great. Practice limits. We have done 2 videos on limits, so we should know enough from those 2 videos that we can handle all the questions I will present in this particular video. I am Mr. Ish and I thank you for joining me for this video. Question number 1, we have to find limit as x approaches -1, 3. The function here is 3. What is our output? What does this 3 really indicate? This right here is your function. Y is equal to 3. You're looking at a horizontal line. Y equals 3. If you're looking here at -1, as x approaches -1 either from the right or either from the left, you look up right over here, your output here will be 3 no matter what. Because anywhere on this horizontal line, your y value, your output will never change. Any point you look on this line in terms of your x value, your output is always 3. So 3 will be your answer. Simply reading it off the graph is easy. Or just thinking of this as a horizontal line which has no change in y, your output is the same no matter where you are on that line. 3 is the answer for this particular question. What about this? Limit as x approaches pi, our function is secant x. What is our output? Remember, think back to the direct substitution property of limits. If that function is a trigonometric function and the a value here as x approaches this a is in the domain of that function, just plug it in and your answer is exactly what you would get in terms of an output. You're really looking at limit as x approaches pi, 1 over cosine x, and you know cosine x has a domain -infinity to infinity. This falls in it. You're looking at 1 over cosine of pi, which is 1 over -1, and that's a -1, and this exactly would be -1 because the reciprocal of -1 is just a -1. This answer would indeed be correct. Whether you look at it from the right side or from the left side, as x approaches pi, your answer should still be the same. Limit as x approaches 2, we have 2x minus 5. This right here is a function. It's a linear line. Linear lines have domains -infinity to positive infinity. This value would easily fall in the domain of this function. You can literally plug this in and whatever you get would indeed be your answer. You'd have 2 times 2 is a 4. 4 minus 5 is a -1, and that exactly would be it. Graphically, how can you show this to be the case? Well, you'd have to graph it. If x value is 0, you're getting a y value here of a -5. If y value is 0, you're getting a x value of 5 over 2. 0 comma -5 is right here. 5 over 2 comma 0 is right here. It's just an estimated, approximated graph. Limit as x approaches 2. Remember, this right here is 5 over 2, which is 2.5. But 2 would be somewhere right here. As x approaches this 2 from the left or x approaches this 2 from the right, you look down and across. Your function has a y value over here of exactly what you're seeing, -1. And that is the reason why your answer here will be true. Right hand and left hand limits will be equal. Therefore, your answer is good. Limit as x approaches 2, we have x divided by x minus 2, a rational function. For rational functions, generally, you can easily plug it in. What you get is your answer. But here, if you put 2 over here, you're seeing that 2 is zeroing it out. It's not in the domain. What's the domain of this function? You would have to calculate the 0. X minus 2 is equal to 0. You're calculating the 0 by looking at the denominator. X is equal to 2. This right here is your vertical asymptote. Your domain for this function is x is an element of all real numbers, but x cannot equal to 2. But this value here you're looking at is in this exception. So therefore it's outside the domain. You cannot plug it in. You just cannot. But you have to now evaluate this limit from a different direction, from 2 different perspectives. Generally here your answer would be does not exist, but we'd have to see if that is indeed the case. You'd have to look at it from the right side and from the left side. Limit as x approaches 2 from the left and limit as x approaches 2 from the right. What can we do over here? Well, come up with some approximated value. If you have a value 2, a value very close to it from the left side would be 1 point and a bunch of 9s. From the right side of 2, a good value very close to it would be this. Plug these values in here and see exactly what you get, and I'll plug them for you. I'll plug this value here into the denominator. I'll do all the 9s on the screen. -2, and I'm getting that, and I'll save it. Then I'll do again 1.99 all the way, divided by that saved value. I'm getting a minus very large number. So that tells me from the left side I'm approaching -infinity. And now I have to do the exact same exercise for the values from the right of this 2. And it's 2.00. And then 1, and I'll minus here in the denominator -2, and I'll save this value. Then I have 2.00001 in the numerator divided by that saved value, and I'm getting a very large positive value. And then I'm seeing this. So I'm seeing that from the right side I have a positive infinity from the left side, I have a negative infinity. The right side and the left side limits are not the same, therefore your answer in general for this does not exist. But as for one-sided limits, it's minus infinity from the left, positive infinity for the right. And the reason for this, as you could imagine, would be the presence of that vertical asymptote. If you were to graph it out, and I'm not graphing it out, I'm just showing you a possible behavior of what's going on. We know here that x is equal to 2 is your vertical asymptote. So when you're approaching this vertical asymptote from the right, what's going on is you're approaching positive infinity, so your curve is going somewhere like that. From the left side, you're having a curve which is probably coming down in this direction, maybe going through the origin here. But remember, this is not exact replication of the curve, but I'm just showing you the behavior at the limit. At the limit, you have a positive infinity here, and you have a minus infinity right over here at the vertical asymptote. Let's look at one more question, and that'll be it for this particular video. Limit as x approaches 0, we have cosecant x. How do we evaluate this? You know cosecant x is 1 over sine x. If you do 1 over sine of 0, you're doing 1 over 0, that's undefined. So you know you're getting an undefined, but we have to do a little bit more than this. How about we graph it out? You know the sine curve looks something like this. And the cosecant would have a vertical asymptote right over here, and you would have a vertical asymptote right at pi, because these are the x-intercepts for the sine, and then they become your vertical asymptotes for the cosecant. Your curve is going to look something like this. X approaching 0, but then you know the sine continues in this direction, as you know, and then you have something which is coming like this. Just by looking at the curve, you know as x approaches 0, your limit here does not exist, because the right side and the left side values are not the same. Here, x approaching 0 from the left, x approaching 0 from the right, you're not having the same answer for these cosecant curves. Don't look at the sine, just look at the cosecant. But from the graph, you can determine your answer. This right here is good answer. But as x approaches 0 from the right, your function is going to go up towards positive infinity. As x approaches 0 from the left, your cosecant is going here towards minus infinity. And that right there would very well be your good answers. But how can you do this in another way? You can think of values very close to 0 on both the right and the left side. From the right side, you can think of a value, let's say 0.00001. From the left side, you can do minus 0.0001. And do the sine of these and then make the reciprocal. Let's keep everything on the degree. You're doing 0.001, sine it, and do reciprocal of it. You're getting a large number. I'm keeping everything on the degree mode because I'm viewing these as degrees, not as radians. So I'm keeping my calculator here on the DEG mode. When I do this, I got a very large number, which I assume to be positive infinity, because as I add more zeros, it'll become positive infinity. From the left side, let's do 0.0001 minus. You can do sine of it and then do the reciprocal of it. You're getting a minus large number. As you add more zeros, you'll get indeed a minus infinity. So the approximation approach and the graphic approach both corroborate the same answer for both the right and the left sides. So these answers are good. But in general, as x approaches 0, the limit does not exist because the left side and the right side answers are not the same. And you will remember that. And that's it for this particular video. Have a good day. Bye.